Hello everyone. So your today experiment is going to be about extraction and sublimation. So today we are going to extract caffeine from tea, in fact from tea bag. Caffeine is a white crystalline solid, and if you test it, it's bitter. Uh, Usually we have caffeine in coffee, tea, cola. On an average, an American consumes 150 milligram caffeine per day. So caffeine is moderately soluble in room temperature water, very soluble in boiling water and organic solvents such as dichloromethane, DCM. In addition to caffeine in a tea bag, which today we're going to extract caffeine from a tea bag, in addition to caffeine, we have cellulose and tannin. So, cellulose is a polysaccharide, and in fact, it's a chain of glucose as monosaccharide. Uh, but tannin is hydrolyzable to glucose and gallic acid. So, glucose is completely soluble in water, but gallic acid is partially soluble in water. To make tannin fully water soluble, so for when we add tannin to water, so it will be hydrolyzed to water, to glucose, which is soluble in water, but the other part, the gallic acid, is partially soluble. So by adding sodium carbonate, we can have the sodium salt of gallic acid, which is completely soluble in water. So to have a completely soluble tannin in water, we need to add sodium carbonate to the water, to the aqueous mixture of tannin. So, as I've mentioned, in tea bag we have caffeine, which is our target compound, uh, hot water soluble and soluble in DCM. We have cellulose, which is completely insoluble in water, and tannin, which we can make it completely soluble in water by adding sodium carbonate. So, for separating cellulose, as I've mentioned, caffeine and tannin are soluble in hot water, but cellulose is not. So easily we can separate cellulose by using filtration from the tannin and caffeine. But in the next step, we need to separate caffeine from tannin. So caffeine is soluble in DCM, but tannin is not. So by using liquid extraction, we can separate caffeine from tannin, and at the last step, by using sublimation, we will have pure caffeine. So the equipment and materials which we need for these experiments are 250 milliliter beaker for brewing tea bag in 100 milliliter boiling water, 5 tea bags, 1 gram sodium carbonate, heating plate, 125 or 150 separative funnel, ring stand to hold separative funnel, few clamps, 40 milliliter DCM dichloromethane in 4 portions, and two right-sized beaker. The first one must be smaller, and the second one must be bigger. They must be fit to each other, and some ice. So the first step is brewing of tea. So you need 250 milliliter beaker. You need to add at first 2 grams sodium carbonate, 100 milliliter water, and then you should add 5 tea bags and let it to boil for 20 minutes. So in this step, as I've mentioned, caffeine and tannin will be soluble in the hot water, but cellulose remain insoluble. So to separate the insoluble cellulose from the tannin and caffeine, you need to do the vacuum filtration. So after vacuum filtration, the brown color water which you will have in the Erlenmeyer is the mixture which you need for your next step. So next step is liquid extraction. So in your brown colored aqueous phase, you have tannin and caffeine. You need to separate them from each other. So caffeine is soluble in DCM, in organic solvents, but tannin is not. So we're going to use this property to separate them from each other. So you need to add all of your brown color filtrate to the separated funnel, and then add 10 milliliter dichloromethane, DCM. So at first, the organic phase, the DCM, will be under the aqueous phase, water, because the density of the DCM is lower. So you need to shake the mixture after using the stopper, closing the separated funnel. You need to shake it and let it a few minutes to see the separated layers again, and then opening the stopcock and let the just organic phase, the DCM phase, go through the beaker. So take care, don't let the brown water go to the beaker. So and for separating the DCM from the water, you need to take out the stopper from the uh, separated funnel to have the air pressure to push it to go down. So you need to repeat these steps 4 times for 10 milliliters DCM, actually 40 milliliter, but you need to use it in 4 different steps. Adding 10 milliliter DCM, shaking, separating the bottom layer, which is DCM. So at the end of this step, you will have 40 milliliter colorless DCM. But if you saw any tiny drop of brown colored water in your DCM, you need to use magnesium sulfate to dry your DCM. So adding magnesium sulfate and filter just using gravity filtration. You don't need vacuum filtration. And filter the solution, and you will have the dry DCM after filtration. So the last step is sublimation. At first, you need to put your DCM on the hot plate, heated, to dry completely the DCM. When DCM dried and evaporated completely, you need to use the smaller beaker, which is fit to the beaker which contains the caffeine, the DCM which was evaporated, and you have the caffeine at the bottom of this bigger beaker. So you need to fill the smaller beaker by using ice and put it in the bigger beaker. So the edge of the beaker, the bigger beaker and the smaller beaker, must be in opposite sides to keep the smaller beaker a little higher from the bottom of the bigger beaker. And you need to have this gap here. So what will happen when you continue heating in this way? So you will have the crystal of the caffeine at the bottom of the smaller beaker contains ice. But we have a common problem. Usually you will see some water drop at the bottom of the smaller beaker. That's why you cannot see the sublimation and you cannot see the crystal of the caffeine. So this happens because you have some water in your DCM. That's why you need to use magnesium sulfate, as I've mentioned already. You need to use magnesium sulfate added to DCM solution to be sure that it's completely dry. So if you follow these steps, at the end you will have the caffeine crystal at the bottom of the smaller beaker, and you can collect it as your final product. Okay guys, that was your today experiments. Good luck.